students, welcome you all to Think Max. We are in class 11 Max, chapter 1, sets. So in the session, we are going to discuss about the example problems 9, 10 and 11. So these problems are based on the concept subset. So what is a subset? So if every element of a set A is in the set B, then we can say A is a subset of B. So for example, suppose A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, 5, 6. Okay. So if we check the element 1 is in B and the element 2 is in B and the element 3 is also in B. So every element of the set A is in B. So if every element of the set A is in B, then we say A is a subset of B. So subset is the relation between two sets. Okay. Subset is nothing but relation between two sets. Just remember this. So this will be helpful in solving example 11. So what is that? So subset is the relation between two sets. Okay. Now we'll move on to the example 9. Consider the sets phi. What do we mean by phi? Phi is a null set. So null set A is equal to set of all 1, 3. B is equal to set of all 1, 5, 9. C equal to set of all 1, 3, 5, 7, 9. Insert the symbol subset. This is the symbol for subset or not a subset. So put a subset symbol and cut it. So not a subset between each of the following pair of sets. The first question is phi between phi and B. That is between a null set and the set B. So what are the proper subsets in set B? So we can say what are the proper subsets in set B? We have a null set, then set of all 1, set of all 5, set of all 9. Then we can say pair it 2 to 1, 5, 5, 9, 1, 9, then 1, 5, 9. Okay. So these are the proper subset of B. So in this 5, what is that? Null set. So null set is in B. So every element is in B. So that means phi is a subset of B. That is all the empty sets are subset of this every set. All empty sets are subset of every set. Okay. So then null set is a subset of B. No need to check it. Empty sets will always be a subset of every set. Okay. Now let us move on to the second question. A and B. So A is equal to 1, 3. B equal to 1, 5, 9. So if you check the elements of A, every element of A should be in B. So if you check 1, yes, 1 belongs to A and 1 belongs to B. Next one, 3. 3 belongs to A, but 3 is not in B. That is 3 does not belongs to B. So if it is not, if it is so, then A is not a subset of B. So every element of A should be a element of B. So here 3 is not an element of B. Then means A is not a subset of B. Okay. So every element of A should be an element of B. So here 3 is not an element of B. So 3 does not belongs to B. So that means A is not a subset of B. Now take A and C. So third question, A and C. So A is equal to 1, 3. What is B? B is equal to 1, 3, 5, 7, 9. So here, if you take the element of A, 1 is in B. So that is 1 belongs to A and 1 belongs to B. Next element is 3. 3 is both in A and B. So that is 3 belongs to A and 3 belongs to B. So every element of A is an element of B. Then we can say A is a, not B, I'm sorry, it is C. Okay, so this is the set C. Okay, so then A is a subset of C. So every element of A is in the set C. That means A is a subset of C. Now what about B and C? What is B? B is equal to 1, 5, 9. And C is equal to 1, 3, 5, 7, 9. So we have to check whether every element of B is in C. 1 belongs to B and 1 belongs to C. What about 5? 5 belongs to B and 5 belongs to, yes, 5 is in C. So 5 belongs to C. What about the 9? 9 belongs to B. 9 is also in C. 9 belongs to C. That means every element of B is an element of C. Then we can say B is a subset of C. Okay, children? I hope you can understand the example 9. So moving on to the next example. Example 10. Let A is equal to set of all A, E, I, O, U. And B is equal to set of all A, B, C, D. Is A a subset of B? Is B a subset of A? So first let us check whether A is a subset of. First one, I am going to check A is a subset of B. We are going to check this. So what is A? A is equal to these vowels A, E, I, O, U. What about B? This A, B, C, D. So if A is a subset of B, then every element of A should be an element of B. Here if you check the small a, both are present in A and B. If you check E, E is an element of A. That is E belongs to A, but E does not belongs to B. If at least one element is not in B, then we can say A is not a subset of B. Okay. No need to check for IOU. Also IOU is not present. If at least one element is not present in B, then A is not a subset of B. Okay. Next we are going to check B is a subset of A. So here B. A belongs to B as well as A belongs to A. Now if you take small b, this small b belongs to B. So every element of B should be an element of A. So if you take the small b, it is not in A. That is B does not belongs to A. So then we have the set B is not a subset of A. So at least one element is not in A. Then we can say B is not a subset of A. Okay, no need to check all the elements. If one element is not in A, then B is not a subset of A. So B is not a subset of A. So not a subset means put the subset symbol and cut it. Okay. So this is the reason why B is not a subset of A and A is not a subset of B. So that means B is not a subset of A. Okay. So moving on to the next interesting example, example 11. Let A, B, C be three sets. If A belongs to B and B is a subset of C, is it true that A is a subset of C? If not, give an example. Okay. So I took this. Okay. I took this example. Here let us check whether A belongs to B. Okay. So belongs to B means the set A should be in B. So A belongs to B means the complete set A should be a set in B. Now if you check A is equal to set of all 1. This set of all 1 should be in B. Yes. So this set of all 1 should be in B. So in B we have inside the curly bracket we have one curly bracket with 1. Okay, so that means the complete set A is in B. So that means A belongs to B. Okay, A belongs to B. Okay, now B is a subset of C. So what is B? B is equal to set of all 1 comma 2. So here if you check B and C, set of all 1 belongs to B and set of all 1 belongs to C. If we take 2, 2 belongs to B and 2 belongs to C. So both these elements, so every element of B is an element of C. That means B is a subset of C. Okay. So this is the subset relation, and belongs to means it is the relationship between element and the sets. Here A. Okay. So in A, the complete element, the complete set is in B. So we write A belongs to B. The complete set is inside the set B. So A belongs to B. So here this elements. What are the elements in B? Set of all 1 and 2. So set of all 1 is in C. Set of all 2 is in C. So that means B is a subset of C. Now we have to check whether A is a subset of C. Okay. So what is A? A has the element 1. So A is nothing but set of all 1. A has the element 1. So is the element 1, that is the element 1 belongs to A. Okay. Is the element 1 is in C? No, it is not in C. That is set of all 1 is in C, not just 1. If we have C as 1, just 1, 2, 3, we will say A contained in C. So we have only 1 belongs to A, 1 does not belongs to C. Can you understand? Here in C, we have set of all 1. That is 2 curly brackets are there. So in A, who is the element? 1 is the element. Okay. 1 is the element. But here, 1 is inside the set. Okay. Inside the curly bracket. Okay. So if it is without the curly bracket, we can say A is a subset of C. But here it is inside the curly bracket. So we can say 1 does not belongs to C. That means A is not a subset of C for this example. So if we have to give example, we can take one example is we can take A is equal to set of all 1 and C is equal to as such. Set of all 1, 2, 3. Okay. So we have now set of all 1 belongs to A. Set of all 1 belongs to C. Okay. Now we can say A is a subset of C. Or now keep A as such. That means 1 is an element. So in this set of all 1 is an element. Now C should be 1, 2, 3. Instead of set of all 1, we should have 1. That we have 1 belongs to A and 1 belongs to C. That means A is a subset of C. Okay. So subset means it is the relation between the sets. That is every element of A should be an element of C. Here belongs to means it is the relationship between an element and the set. Okay. So it is the relationship between the element. So this is the element and this is the set. So it is the relationship between the element and the set. Here the complete set A is in B. Okay, so the set is set of all 1. The set of all 1 is in B. So we write the set A itself belongs to B. Okay, so just understand this, set A belongs to B and the element belongs to B. So here 2 is an element of B and C is an element of B. Okay, so we write 2 belongs to B. Here the set A is completely in B. So we can write A belongs to B as well as A is also in C. So we can write A belongs to C also, but it is not needed in this problem. Okay. So here we have to check whether A is a subset of C for this example. So for this example, it satisfies the condition A belongs to C, A belongs to B and satisfies the condition B is a subset of C. So if these two conditions are satisfied, but this condition is not satisfied, okay, A is not a subset of C. When will this be a subset? So if we take the example as A is equal to set of all, set 1 and C is equal to the same set, then we can say A is a subset of C. Okay, so it will satisfy this condition because A belongs to B. A belongs to B means the set of all 1 is in B. So we can say A belongs to B. So B is a subset of C. So B is a subset of C. Yes, B is a subset of C. So if it is so, then A is a subset of C. So if these conditions are satisfied, we will get this result. Okay, children. I hope you can understand this example. If you are clear with this example, just show your support by subscribing to this channel and hit the bell button so that you get the notification whenever I upload my videos. Also, share this video among your friends and relatives and just show your support by hitting the like button also. Thank you. Thank you for watching.